Hi everyone, thank you for joining me. I'm Eileen and we are looking at Eileen Chevalier's typewriter alphabet flashcards today, and we're going to learn about nectaries. Pollinators aren't just helpful gardeners. They are in search of food for themselves and their colonies. Nectar is what draws most pollinators. In this lesson, we'll search out the secrets of the hidden nectaries. Now, last lesson we did pollinators, so we learned that pollinators are animals that help to take the pollen and put it onto the stigma, from the anther to the stigma, so that the plant can make seeds. So that's what a pollinator is. Now, pollinators aren't just like really nice people or animals. Bees do not just pollinate flowers for fun. They do it for food. That's how they live. So we're going to get a couple of books today. Obviously, you're going to want to have your typewriter alphabet flashcards. The ones that we are going to use are the 9 card. So that is the Nectar Guides. And the 1 card, and that is a nectary, a special kind of nectary. It's in a spur. But this one tells you how to get there. And then that's what they're searching for, is the nectar. Then we're going to look at 2 books. The Ultimate Visual Dictionary, right here. And my favorite giant book, Flora, also DK Smithsonian. Alrighty. So first, go ahead and pull out your journals and I will read some definitions to you. We have 3 definitions, so get ready. The first one is nectar, sugary liquid produced by flowers to attract pollinators. Nectaries, those are special plant parts that store nectar. Nectar guides, which are the markings on flowers that lead to the nectaries. All right, so first question, how and where is nectar made? Why would a plant spend so much of its resources creating food for animals instead of using that food for itself? So we know that plants photosynthesize and they're making sugars for themselves. This is how they have the energy to grow roots and make new branches and make new leaves so they can photosynthesize more, so they can do all these other things all over again. So whenever they create a flower, it's costing them. That is a cost that the plant has to spend a bunch of energy to create this flower. And then whenever it puts nectar, this sugary deliciousness into the flower, that is like, that's sugar. So it's costing the plant a lot to put that into the flower. And not every flower does that. Like orchids are a little devious and they tend to just use deception instead of nectar to get their pollinators to come to them. So, but they do it with color. So they're still drawing and the pollinators in with something, but they're just not giving them what they promised. But why would it spend so much energy making this nectar, right? Like the plant must really, really need something in order for it to go through this much trouble to make this nectar. How is this relationship a win-win? So let's think really simple. Let's just think about bees and sunflowers. There's a big old sunflower behind me. So bees and sunflowers. So the sunflower wants to make sunflower seeds, but it can't do it on its own. And the bee really needs to eat, and it can't do that on its own. So how is that a win-win relationship when the flower makes nectar and provides it for the bees, and also pollen, because bees eat pollen as well as spread it around. That's like their highest source of protein. So it's being fed multiple ways. And then how is that helping the bees? Like, how is it also beneficial for the bees to have this plant to be able to go to and get the pollen and get the nectar from? So win-win relationships are the ones that make it over the long haul. Because if it were only good for one of them, they would not keep doing that. If it was just costing the plant to make the nectar and it wasn't receiving a benefit, it would not keep producing that nectar. That would cost the plant too much. but because it is getting something in return, which is pollination, then it's willing to keep doing that. And same thing with the plants. The bees are not going to keep returning to a plant that doesn't feed them. They won't. They will go to another plant that will feed them. So it has to be beneficial for both parties. Could it also be called survive, survive? So let's think about what would happen. I know that it's super beneficial for them, but is it also about survival? So let's say we have the sunflower and the bee, and I know that bees can eat a lot of other things, and sunflower, a lot of different other flowers, and then the sunflowers can have a lot of other pollinators, but let's pretend like we're just gonna narrowly focus. So what happened to the bees if the sunflower didn't produce nectar and didn't provide flowers with pollen and all that? What would happen to the bee? And then what would happen to the sunflowers? Sunflowers are annuals. They're going to die. They're going to make that flower, and all those little blooms are going to happen, and then they're going to just die and fall to the ground. And so whether they got pollinated or not, the flower's done. It doesn't take long. It's a matter of weeks or months, and then the plant doesn't have next year. It only has this year. So what happens when that pollinator isn't there? So is that absolutely necessary for its survival? And is that part of why the plant is so willing to provide nectar so that it can get those pollinators? Secondly, nectar guides can be beautiful for us to look at, but did you know that there are many nectar guides that we can't see? No, I know. You thought it was all about the plants just looking pretty, but that's not what it's all about. What can see them? So why would it have colors that we can't see? Obviously, this is a more recent development that we can understand that, and maybe there are things we don't even know that it can do yet because we can't sense them, though some other animals can. Look at examples of UV guides in the Visual Dictionary and Flora. Why might the flowers use colors that we and maybe other animals can't see? And why might it use both? So colors we can see and colors we can't see. Why would it need to do both? Or why would it want to do both? So let's look at this page. So we were just looking at the 9 nectar guides card, and this happens to be a toad lily. I did not have this book when I picked that as 9 nectar guides, but this is indeed a toad lily, which is really cool. So you can get to see it, and it's a little bit different looking than one that I drew, but very similar, the purple, and then they have these really cool yellowish orange spots there as well. But that's not the part we're looking at. What we're looking at is this right here. So this is showing you the UV colors. So the yellow one was in daylight and the other one is in ultraviolet light. So bee's eye view. Bees lacked the photoreceptors necessary to see colors like red. But their ability to discern ultraviolet light transforms seemingly plain surfaces into complex patterns. What we see is a plain yellow marsh marigold. A bee perceives as a light-colored bloom with contrasting dark center, effectively a bullseye, proclaiming land here. So let's look at that again with that in mind. So this is what we see, and this is what the bee sees. I think it's really interesting because humans have been selecting plants for a long time. And so we will breed plants and we'll select plants based on what they look like to us. So how they look can determine how much we want to propagate them, right? So we can do a lot of work for the plant and help the plant to grow and proliferate in the world based on what the colors it shows us are. But bees want to see the ultraviolet part. And really the flower wants the pollinators. So here's another one that's amazing. All right, this is the hollyhock. So this is what we see. Nice, pretty white flower. And this is what the pollinator sees. So way cooler. That's the ultraviolet, what happens in ultraviolet light, which is what's happening from the sun. The fluorescent hollyhock. When a hollyhock is made to fluoresce under UV light, its bullseye pattern is revealed. As well as guiding pollinators to nectar, such markings may also help pollinators distinguish between flowers that look much the same to human eyes. So there are a lot of plants, and we call them like imitators. So there'll be this plant and another plant that looks very similar. We think of this a lot of times in poisons. So we're like, oh, that plant's poisonous. And then there's this other plant which is totally harmless, but it looks poisonous, and then things don't bother it because it looks like the other one. But the UV markings allow the bees to tell the difference between two different types of plants. Observe a variety of nectaries. You can look at flowers, pictures, diagrams. There are lots of great ones in these books. Where are they located? Why do plants place nectaries where they do? What is the plant's goal? Why isn't there a larger amount of nectar? What would happen if flowers produced twice as much nectar? All right, so again, we're talking strategy here. So I'm going to read these really quickly. I'll read the 9 nectar guides, even though we already talked about that. Nectar is a sugary liquid that flowers produce to feed pollinators. How do pollinators know where to find it? There are 9 highlighted nectar guides on this toad lily tepal. The guides, which are just the dots, show pollinators, such as bees, where to find the nectar. Do you see the rounded nectaries at the base of the tepals? So, right there at the base. So here are the guides, and so they're like, this way to the pollen, or to the, well, they want pollen and nectar, but this way to the nectaries. So here is the nectar down here. It's at the base. It's the very base. And then let's compare that with the nasturtium. Nasturtiums have a long spur on the back of the flower where they store nectar. Nectaries are where flowers store the nectar, a sugary liquid that bees, hummingbirds, and other pollinators eat. I mean, if you've ever eaten honeysuckle, then you also have experienced eating from a nectary. So where is this one? Here's the stem of the flower, and here's the very back, right? Kind of like with our 9 nectar guides. You have to go all the way to the base, all the way to the back of the flower. So why is it putting them there? Why doesn't it just put them out on the tips of the petals, you know? Why does it want to hide them and make the pollinators come all the way through the flower to get to that nectar? And then what if they made just a ton more nectar? Would it attract more pollinators? Would the bee go, I'm full. I can just keep coming to this one and not go to any of the other ones, and this one's good. Would it spend so much that the flower could only make half as many flowers because it took so much energy to put all that nectar into them if it put in more nectar? That's just a theoretical question for you to think about. All right, in your journal, there are a couple of activities you can do. Look through the flashcards and identify any nectaries or nectar guides. Why can't you find them in every picture? So these 2 are really easy, which is why I chose them for this lesson. But sometimes it doesn't even look like they're there at all. My favorite one that I ever found was the peach. I mean, the peach nectar is amazing. So I did a video where I go through all the stages of peach blossom, and you should definitely watch that one. It's really cool. It's bright orange inside the flower, and that's where the nectar is, down there at the base. You can't see it. It closes up, and then the petals come out like this. So this whole bottom part is where the nectar is. So you can't really see it normally. I did draw a peach flower. That's when I found it. So let's see if we can see it in the picture. Yes. Oh man, it was one of the highlights of drawing these. So there you go. See the orange right there? And it's not that it's like wet, right? So it's, some of the nectaries are like really oozing, and it depends too when. So it's like they want the pollinators there at a particular time, and then once the anthers don't have any more pollen, and once the pistil has already gotten the pollen in there, then, and it's already been fertilized, it doesn't need that anymore. So there's only like a limited amount of time that nectar really needs to be there to draw in those pollinators. So anyway, The colors change over time. I happen to pick these at like the perfect moment. And so sometimes you pick a flower and it's just a little too early or a little too late, and you're like, I don't understand why I don't see this nectary. But it happens, like there's a time that it's all happening in. So that might be one reason that you don't see it. And for me too, like I did the drawings at a particular moment in time, so it's much more likely that you're going to pick a flower when the nectaries are not in full swing than when that you will hit it perfectly right on. And then some of them, just because of the way that they need to be pollinated and the way that their relationship that they have with their pollinators, they don't have that same need for the for the pollinator to get way into the plant. So every relationship is different between the animals and the plants. So print some coloring pages and label the nectaries and the guides. Include the flower's pollinators if you know. So some good ones you can use are N or 1, both of those are nasturtium, T or 9, both of those are toad lily. And then you can also do A, H, I, O, T, U, and X. Like those are some other good ones that are really, really easy. The X was super easy. That was like my first version of the cards. The X was in Nectar Guides because those are really easy to see as well. Orchids, just a note, again, I said this earlier, but orchids are very deceptive. They may have nectar guides, but no nectar. So they're pretty tricky. Reading up on orchids is pretty fun. So you might want to look at that and see what their relationship with their pollinators is as well. Second thing you can do is to gather living flowers and with visible nectaries and draw the flowers yourself. So label the nectary, the flower name, the pollinator if you know it, and observations about the nectar guides. And you can include the color and the scent. If you could have access to see it under UV light, that would also be a really cool thing to look at. But try to think about all the things that might be attracting a pollinator that you can observe. So the smell, the taste. Think about what might be, the plant might be protecting itself from the wrong types of animals. So what is it about the plant that might be, and if you watch the protection video, then you can get some other ideas like when you actually look at these plants. So like it might be doing some things that to like the borage that we looked at earlier to like keep away certain animals that wouldn't be the ideal pollinator. All right, so go ahead and start looking for those and put them in your journal, and we will see you guys next time. Thanks for joining me. Bye.